Good day. Today we're going to discuss the polar coordinates. So up to now, we have specified the location of a point in the plane by means of coordinates relative to the two perpendicular coordinate axes. However, sometimes a moving point has a special affinity for some fixed point, such as a planet moving in an orbit under the central attraction of the sun. In such cases, the path of the particle is best described by its angular direction and its distance from the fixed point. In this discussion, we will have a new kind of coordinate system that is based on that idea. So let's start with the polar coordinates. So when we are talking about polar coordinates, uh, a polar coordinate system in a plane consists of fixed point O, which called pole or origin, and a ray emanating from the pole called the polar axis. In such coordinate system, we can associate with each point P in the plane a pair of polar coordinates, okay, r theta, where r is the distance from P to the pole and theta is the angle from the polar axis to the ray OP. So when we are going to illustrate that one, okay, so you have point O, so this is our origin, and then this is our polar axis. Imagine that this is a straight line. And then let's say that uh, this polar axis is moved to a certain angle. Let's call this is theta. And this now is our point P. So this is array P. Okay. And this point P, uh, ray OP with point P. Okay. So the point P has the coordinates of R, which is the distance of the point P to the origin or to the pole. Okay. And then you have the theta, which is the angle formed with this movement. Okay. So the number r is called radial coordinate of P. So this is the radial coordinate of P, and the theta is called angular coordinate or polar angle of P. So when we have the points, for example, we have the point uh, 6 pi over 4. So let's try to write this one. So if you have 6 pi over 4, okay, and then you have another point, let's say 5 2 pi over 3, and then you have 3 5 pi over 4, and let's say you have 4 11 pi, oops, 11 pi over 6. Okay, if we are going to plot this one, if we are going to plot this one in the polar coordinate system, then we could have, let's say, this one, the 6 4 pi over 4. Then this is your angular, this is your polar axis, and then you have the rotation of angle at pi over 4, and then when, oops, sorry, okay, so it means to say that this point is 6 units away. 1 2 3 4 5 6 is 6 units away, okay, from the origin. And then if this would be the point, then we could have this one, and then the angular is let's say this is 2 pi over 3, That's not realistic. Let's move that one. Something like that because that is obtuse angle. And then if this P has the coordinate of 5, 2 pi over 3, it means to say that you have 5 units from here. So 1, 2, 3, 4, 5. Okay. And then this one, then you could have something like this. So if this is your polar axis, and you have 5 pi over 4 as your rotation or your uh, angular coordinate. So it means to say that you have something like this. So you have this one. And this is 3 units away. So this is 1, 2, 3. And of course, if you have 4, 11 pi over 6, then you have something like this one. So something like this. And that is your, so 1, 2, 3, 4. And this is 11 pi over 6. Okay. So if P is the pole, then R equals 0. Um, there is no clear defined polar angle. We will agree that an arbitrary angle can be used in this case. So that is if you have 0 theta is the coordinate, um, the polar coordinates of the pole for all choices of theta. Okay. So the polar coordinates of the point are not unique. You have to take note of that one. Let's have an example. If you have 1 7 pi over 4, and then you have 1 negative pi over 4. Okay. And then you have another 1 15, that is 15 pi over 4. If we are going to have this one in the um, this coordinate system, the polar coordinate system, if this is our polar axis, and then let's try to have a 7 pi over 4, then you have something like this one. Okay. So let's say this is our 7 pi over 4. 7 pi over 4. And then if you have negative pi over 4, that is this one. Okay, this is our negative pi over 4, which has the same length. This is the same r, 1. And then if you have 15 pi over 4, it means to say that there is one full revolution. So you have this one full revolution, and then another movement. And this is our 11, this is our 15 pi over 4. So it means to say that these points are the same. So that's why that the polar coordinates of a point are not unique. Okay. So in general, if a point P has the polar coordinates are theta, then okay, if you have uh, let's say you have the coordinates of uh, r theta, then we could say that r theta plus 2n pi, and you have r theta minus 2n pi are also uh, polar coordinates of P for any non-negative integer n. Thus, every point has infinitely many pairs of polar coordinates. So, as defined, the radial coordinate r of a point P is non-negative since it represents the distance from P to the pole. However, if we will be convenient to allow for negative values of r as well, to motivate the appropriate definition, consider the point P with a polar coordinates. You have 3, 3, 5 pi over 4. So let's have, you have 3, this is 3, 5 pi over 4. Okay. Now, if we are going to have that one, you have 3, 5 pi over 4. If we are going to illustrate that one, if this is our okay, polar axis, then you have 5 pi over 4 as its angular coordinates. Okay. And then you have um, 3. 1, 2, 3. Mm. Now, we can reach this point by rotating the polar axis through an angle of 5 pi over 4 and then moving 3 units from the pole along with the terminal side of the angle. Or we can reach the point P by rotating the polar axis through an angle of uh, pi over 4. So if we are going to rotate this one as 5 over 4, so this is pi over 4. Okay. Then moving 3 units from the pole, something like this. Let's say something like that. So we can form actually a straight line. Okay. So this suggests that 3 5 pi over 4 might also be denoted as negative 3 4 pi, 4 over 5 pi, with the minus sign serving to indicate that the point is an extension of the angle's terminal side rather than on the terminal side itself. So in general, the terminal side of an angle, uh, the terminal side of an angle theta plus pi is the extension of the terminal side of theta. So we define the negative radial coordinates by agreeing that you have negative r theta and you have r theta plus pi are polar coordinates of the same points. Okay, so let's have the relationship between the polar and rectangular coordinates. Frequently, it will be useful to superimpose a rectangular xy coordinate system on top of the polar coordinate system, making the positive x-axis coincide with the polar axis. If this is done, then every point P will have both rectangular coordinates xy and the polar coordinates of r theta. So if we are going to uh, plot that one in the xy coordinate system, so this would be the okay, so this would be the uh, illustration. So in this case, these coordinates are related by the equation. You have x equals r cosine theta and y equals r sine theta. These equations are well suited for finding x and y when r and theta are known. However, to find r and theta when x and y are known, it is preferable to use the identities. You have sine squared theta plus cosine squared theta equals 1. And another is tangent theta is equal to sine theta over cosine theta. So if we are going to rewrite that one, then our r squared is equal to x squared plus y squared. Now, we could also have the tangent theta is equal to y over x. So that's how we can use the concept of trigonometric function or trigonometric identities to be exact. Okay, so let's have this example. Example number 1. Find the rectangular coordinates of the point P whose polar coordinates are r theta equals 6, 2 pi over 3. Now, if we are going to illustrate that one in the xy coordinate system. Okay, so if not the xy coordinate system, if we're going to plot this one into the graph, so you have something like this. If this is our polar axis, oops, let's make it straight. Okay, and then it is rotated at, you have 2 pi over 3. So something like this. So this is 2 pi over 3. Let's try to rewrite. So somewhere here, and then let's say this is your 2 pi over 3. And then you are going to draw from the pole 6 units. So you say 1, 2, 3, 4, 5, 6. So this is our P, okay, which is 6 units. Now, if we are going to find the rectangular coordinates of point P, what we are going to do is we are just going to substitute the polar coordinates. The r is equal to 6, and our theta is equal to 2 pi over 3. Okay, so you have x equals 6 cosine 2 pi, okay, over 3, which is equal to 6 times cosine 2 pi over 3 is equal to negative 1 half. And of course, 6 times negative 1 half is equal to negative 3, which yield that y is equal to 6 sine 2 pi over 3, which has uh, can be solved as 6 sine 2 pi over 3 is equal to square root of 3 over 3, which is, if we are going to multiply that one by 6, that is 3 square root of 3. In other words, the rectangular coordinates of P, okay, in xy coordinate system would be negative 3, 3 square root of 3. So in other words, this point, which has a polar coordinates of 6, 2 pi over 3, is just the same to the xy coordinate system with the point whose coordinates is negative 3, 3 square root of 3. Okay, let's have another example. Find the polar coordinates of point P whose rectangular coordinates are negative 2, negative 2 square root of 3. Now, if we are going to plot that one in the rectangular coordinate system, then you could have something like this. Since this is negative 2, negative 2 square root of 3, that is in the third quadrant. So if this would be our rectangular coordinate system, somewhere here, let's say, mhm, this is 1, 2, then 1, 2, 3, somewhere here. And then you can write that one here. Okay, so we will find the polar coordinates in r theta of P that satisfies the condition. We have the condition that r must be greater than 0, and you could have the theta must be greater than or equal to 0, of course, and because it is in the third quadrant, then it should be less than 2 pi. Okay, so from the equation presented before, okay, in the previous slide, that you have r squared is equal to x squared plus y squared, and tangent theta is equal to y over x, then we can use the concept of that r squared. So you have r squared is equal to x squared plus y squared. Now substitute, then you have negative 2 squared plus negative 2 squared of 3 quantity squared, which is equal to 4 plus this one. This is 4 times 3, which is equal to 12, which is equal to 16. So in our R, okay, our R would be 8. Square root of 16 is 4 rather. Okay, so in this second equation in the previous slide, which is tangent theta is equal to y over x, we can use that concept. So you have tangent theta is equal to y over x. Substitute, you have negative 2 square root of 3 over negative 2, which is equal to square root of 3. That is our tangent theta. From this and the fact that you have negative 2 square root of 3 lies in the third quadrant, it follows that the angle satisfying the requirement that theta is greater than or equal to 0 but less than 2 pi would be, in this case, your theta would be equal to 4 pi over 3. Thus, our P with the coordinates of uh, r theta would be equal to 4 pi over 3 as the polar coordinates of P. At all other polar coordinates of P are expressible in the form of, so you could have, because there are many points that has this, there are many coordinates of the point P that is equivalent to this coordinate. So by extension, all other points of this 4 pi over 3 could be 4 pi over 3 plus 2n pi. Okay, because you have the period of 2n pi. Or it could be also equal to negative 4 pi over 3 plus 2n pi. So these points, these expressions, okay, are the same where n is an integer. Okay, so given in an equation in r and theta, we will define the graph of polar coordinates to consist of all points with at least one pair of coordinates uh, pi theta that satisfy the equation. So for example, we're going to sketch the graph of r equals 1 in the polar coordinates. So for all values of theta, okay, so for all values of theta, the point 1 theta is 1 unit away from the pole. Since theta is arbitrary, the graph is a circle whose radius 1 center. So since this is arbitrary, so any values if of theta can be substitute. So in other words, if that is the case, if we are going to graph this one in the polar coordinate system, then you could have, okay, something like this one. Okay, the radius is 1, and because the angular coordinates is arbitrary, then we can form a circle. So assuming that this is a perfect circle. Okay, so let's have this one. Sketch the graph of theta equals uh, pi over 4 in polar coordinates. So in this case, all values of r, the point you could have here, you could have the point r pi over 4. If we are going to graph this one in the polar coordinates, take note that r is an arbitrary, then we can form a line here. So in this case, if this is our uh, polar axis and you have the rotation up to pi over 4, then you could have a straight line, something like this. So our theta here is 4 over pi. Okay, so the positive values of r corresponds to the points on the line in the next quadrant, and the negative values of r 2 points in on the line in the third quadrant. Okay. Thus, in absence of any restriction of r, the graph is the entire line. Observe, however, that we imposed the restriction that r is greater than equal to 0. The graph would have been just a ray in the first quadrant. Okay, so let's have sketch the graph of r equals theta, where theta is greater than or equal to 0 in the polar coordinates by plotting the point or plotting points. So the equations r equals the function of theta that express r as a function of theta are specifically important. One way to graph such an equation is to choose some typical values of theta, calculate the corresponding values of r, and then plot the resulting pair r theta in the polar coordinate system. So the solution for this is observe that as the theta increases, so does the r. So take note that as our theta increases, so does r. Thus, the graph is a curve that spirals out from the pole to theta increases. A reasonably accurate sketch of the spiral can be obtained by plotting the points that corresponds to the values of theta that are integers multiples of pi over 2, keeping in mind that the values of r is always equal to the value of your theta. So take note that since you have r is equal to theta, what will happen is that if you have this one, so of course, if it is 0, r is 0. If it is, let's say you have pi over 2, so somewhere here. And then if it is pi, so somewhere here. And if it is 3 pi over 2, it is somewhere here. And then it is 2 pi, so here. Mhm. Then this is 5 pi over 2. This is 3 pi. This is 7 pi over 2. This would be 4 pi. And of course, this would be um, 9 pi over 2. So somewhere like this. Okay, this is a spiral. So as you can see, it increases its with this is a spiral. Okay. Okay. So let's have sketch the graph with the equation r equals sine theta in the polar coordinates by plotting the points. Okay. So in this case, take note that our r is equal to sine theta. Then we can show now the points, uh, the coordinates of the points on the graph at increments of pi over 6. So you could have this one. So if our theta is, let's say, equal to 0, our r would be equal to, okay, 0. And of course, the coordinates at r theta would be equal to 0, 0. Okay. Now increment by pi over 6. So pi over 6. If our theta is pi over 6, substitute here. So sine pi over 6 is equal to 1 half. In other words, this would be equal to 1 half. Then you have uh, pi over 6. Okay. Now, since we have an increment, so you could have pi over 3, and the r, substitute the pi over 3, you have square root of 3 over 2. So in other words, the coordinates is, you have square root of 3 over 2 and pi over 3. Okay. So next you have pi over 6. No, that's pi over 2. Okay, pi over 2. Then you have 1. Therefore, this coordinate would be 1 pi over 2. Okay, next, you could have 2 pi over 3. So if, hey, what happened? So 2 pi over 3, if we are going to substitute that one to our pi, not pi, or our theta, so um, you could have 2 pi over 3 is equal to square root of 3 over 2. So you could have 2 pi, wrong. It should be square root of 3 over 2, 2 pi over 3. Next, you could have 5 pi over 6. If we are going to substitute that onto our theta, that's equal to 1 half. Therefore, the coordinates is 1 half 5 pi over 6. Next, since it is a 5 pi over 6, you could have pi. And of course, the r is 0, which is the coordinates of 0 pi. Okay. Next, you could have 7 pi over 6, which is equal to negative 1 half. Therefore, this is negative 1 half 7 pi over 6. Next, you could have 4 pi over 3. And then substitute that one to our equation, which is r is equal to sine theta. Then you could have negative square root of 3 over 2. Okay. So you have negative square root of 3 over 2, 4 pi over 3. Next, you could have 3 pi over 2. And then your r here would be equal to uh, 3 pi over 2. That's equal to negative 1. Therefore, the point would be negative 1, 3 pi over 2. Next, you could have 5 pi over 3. If we're going to substitute the 5 pi over 3 to the equation, you could have negative square root of 3 over 2. Then, this would be negative square root of 3 over 2, 5 pi over 3. Then you could have uh, 11 pi over 6. And if we are going to substitute that one, that would be negative 1 half. And You could have negative 1 half 11 pi over 6. And the last one would be 2 pi. So if it's 2 pi, that's 0. So you have 0, 2 pi. As you can see, it will, uh, what we call this one, it will uh, go back to its, to the other points. Okay. So if we are going to plot that one, okay, if we are going to plot that one, so how should I start? Let's start with the origin because it is 0, 0. So this is the first point. Then the second point is 1 half uh, pi over 6. So if this is the polar axis, and then you have these points. So you have this one. Next, somewhere here. Okay, this one. So this is 1 half uh, pi over 6. Then this is square root of 3 over 2 pi over 3. Next, you have 1 pi over 2. So somewhere here. So this is 1 uh, pi over 2. And then, of course, you have this one. Okay. This point would be equal to uh, negative square root of 3 over 2. Not negative. That must be positive. Sorry, sorry. Then the angular is 2 pi over 3. And then you have this one. So somewhere here. This is 1 half 5 pi over 6. And then, okay, one. And then you have, uh, again, you have pi 0 or 0 pi. So 0. So somewhere here. Actually, it will just be, okay, you have 0 pi because take note that in this case, pi is actually uh, somewhere here kasi 0 siya. Mm. So we can confirm that uh, the polar equation pi equals sine pi in terms of x and y. Um, we can multiply the equation through by r to obtain, let's say you have r squared is equal to r sine theta. So which now allows us to apply the formula. You have x squared plus y squared equals y. Okay, because we can apply the previous formula. So you could have x squared plus y squared equals y. And then rewriting this one, so you could have x squared plus y squared minus y equals 0. And then by completing the square, we could have x squared plus, you have y minus 1 half quantity squared is equal to 1/4, which is, of course, a circle of a radius 1 half centered at the point 0, 1 half in the x coordinate xy plane. So Actually, this is a circle. So although that this is not something like circle, but this is a circle. Okay. Uh, it is often useful to view the equation r equals function of f of theta as an equation of rectangular coordinates rather than polar coordinates, and graph in a rectangular uh, pi, pi r coordinate system. Okay. So instead of plotting the points, we will use the graph of r equals uh, cosine 2 pi. So if we are going to graph in the rectangular coordinate system, the r equals cosine 2 theta, okay, we could have something like this taken from your previous mathematics. So the amplitude is 1 and this would be negative 1. Okay, so here, this one. So let's say you have this is pi over 2, and then you have pi, then you have 3 pi over 2, and then of course this is 2 pi. So you start with here, and then something here. So the crease is here, there. So you could have similar to this one. Okay, but it's just a sketch. Okay, so we are going to use this graph to visualize how the polar graph of each equation is generated. But later on, we are going to have a very thorough example of how we can sketch this equation into the polar coordinate system. So by analysis, if we are going to have the analysis now in the polar coordinate system, okay, if this is our polar coordinate system, from here, from here, okay, r varies from 1 to 0 as theta varies from 0 to uh, pi, uh, from 0 to pi over 4, because this is pi over 4. So in other words, you start it here. Okay, varies from 1 to 0 as pi varies from 0 to pi over 4. So somewhere here. Okay. Next, r varies from 0 to negative 1 as theta varies from pi over 4 to pi over 2. So in other words, somewhere here. And then r varies from negative 1 to 0 as pi varies from uh, pi over 2 to 3 pi over 4. Somewhere here, something like this one. And then r varies from 0 to 1 as pi varies from 3 pi over 4 to pi. So in other words, something like this one. Okay. And then r varies from 1 to 0 as pi varies from pi to 5 pi over 4. So somewhere ups, something like this one. Okay. And then r varies from 0 to negative 1 as theta varies from 5 pi over 4 to 3 pi over 2. So somewhere here. Okay. And then r varies from negative 1 to 0 as theta varies from 3 pi over 2 to 7 pi over 4. So somewhere like this one. And then r varies from 0 to 1 as theta varies from 7 pi over 4 to 2 pi. So somewhere here, and then it will return. Okay. So in this case, uh, the analysis of this one is the curve is similar to a flower with four petal. So actually, this graph is called four petal rose. Later on, we are going to have another example for how we are going to sketch a graph. Okay. Now, let's have the symmetry test. Um, Observe that the polar graph of r equals cosine 2 pi in the previous slide is symmetric about x axis and y axis. This symmetry could have been predicted from the following theorem, which suggests um, which suggests that this is the uh, symmetry test. So a curve in a polar coordinates is symmetric about the x-axis if replacing theta by -1 in its equation produces an equivalent equation. So that is actually this portion, this one. Okay. Now, a curve in a polar coordinates is symmetric about the y-axis if replacing theta by pi minus theta in its equation produces an equivalent equation. So something like this one. Mm. And then the last one, a curve in a polar coordinates is symmetric about the origin if replacing um, theta by plus pi or replacing r by -r in each equation produces an equivalent equation. So we have to remember that one. So again, it is symmetric about the x-axis if we are going to replace theta by negative theta. Okay, and it produces the same or equivalent equation. And then it is symmetric to y-axis if replacing theta by pi of minus theta in its equation, and then it produces the same equation. And it will be symmetric about the origin if replacing theta by theta plus pi or replacing r by -r in each equation produces an equivalent. Okay, let's have an example. Use the theorem to confirm that the graph of arm equals cosine 2 cosine is symmetric about the x and y axis. Okay, so in this test, uh, to test the symmetry about the x axis, we replace theta we replace theta by negative theta. So r equals cosine -2 pi and -2 theta. Okay, because we are going to replace the theta by negative, which is of course the cosine -2 theta is actually equal to cosine 2 theta. They are just equivalent to each other. So thus replacing theta by negative theta does not alter the equation. So in other words, this is the equation or the graph is symmetric about the x-axis. So to test the symmetry about the y-axis, we replace theta. Okay, so we replace theta by you have uh, pi minus theta. So this yields that r equals cosine 2, okay, times the quantity pi minus theta. Of course, by distribution, you could have cosine 2 theta, 2 pi minus 2 theta. And of course, if we are going to have this one, cosine 2 pi is equal to 0. So in other words, cosine negative 2 pi. And that would be equal to, of course, cosine 2 theta. Thus, replacing theta by pi minus theta does not alter the equation, which shows that the r equals cosine 2 theta is symmetric about the x-axis and the y-axis. Okay. Sketch the graph of r equals a times the quantity 1 minus cosine theta in polar coordinates, assuming a to be a positive constant. Okay. So observe, to solve this one, we have to observe first that replacing theta by negative theta does not alter the equation. Okay. So we know in advance that the graph is symmetric about the polar axis. Thus, if we graph the upper half of the curve, then we can obtain the lower half by reflection about the polar axis. As in our previous examples, we will first graph the equation in a rectangular theta r coordinates. This graph, okay, can be obtained by rewriting the given equation as r equals a minus a cosine theta. Okay, so you have r is equal to a minus a cosine theta. Okay. In this case, which we see if we are going to graph that one, hmm, if we are going to graph that one in xy coordinate system, okay, in the graph in the theta r coordinate, we can obtain the first reflection of the graph. Uh, of course, r equals a cosine theta. So in this case, if we are going just to use, we are just going to get the upper half. Okay, because we know that uh, this is symmetric with respect to x-axis. Okay, so by graphing that one, as theta varies from 0 to pi over 3, r increases from 0 to a over 2. So in other words, okay, if this is our axis, okay, so here, from here, it varies as theta varies from 0 to pi over 3, r increases from 0 to a over 2. So let's say you have this one somewhere here. And then as theta varies from pi over 3 to pi over 2, r increases from pi over 2 to a. So this would be doubled. Okay. And then as theta varies from pi over 2 to 2 pi over 3, r increases from a to 3a over 2. So somewhere here. And then as uh, theta varies from 2 pi over 3 to pi, r increases from 3a over 2 to 2a. So somewhere here. Okay, so if we are going to sketch the graph, you have this graph. Something like this. And then we're just going to imagine to flip it over the x-axis. In other words, you could have the second half. Something like this. Okay. So this heart-shaped curve is actually called cardioid, which is taken from the Greek word kardia, which means heart, because this is something like heart shape. So here this is A, and then this is 2A. Okay. And of course, this is also A. Okay. Sketch the graph of r squared equals 4 cosine 2 theta in polar coordinates. Okay. This equation does not express r as a function of theta, since solving for r in terms of theta yields two functions. And what are those functions? You could have r equals 2 square root of cosine 2 theta, and the other one is r is equal to negative 2 square root of cosine 2 theta. Thus, the graph of the equation r squared equals 4 cosine 2 theta will have the graph um, of two functions separately and then combine those graphs. So let's start with the graph of r equals 2 cosine uh, r equals 2 square root of cosine 2 theta. So observe that this equation does not change if we replace theta by negative theta, or if we replace theta by pi minus theta. Thus, the graph is symmetric about the x-axis and the y-axis. This means that the entire graph can be obtained by graphing the portion of the first quadrant, reflecting that portion to the x-axis to obtain the portion of the second quadrant, then reflecting those two portions about the x-axis to obtain the third and the fourth quadrant. So to begin, uh, we will graph the equation r equals 2 square root of cosine 2 theta in the rectangular theta r coordinates. Okay. Note that there are gaps on the graph over the intervals theta is greater than pi over 4 but less than 3 pi over 4, and of course theta theta greater than 5 pi over 4 but less than 7 pi over 4, because the cosine to theta is negative to those values of theta. So from the graph we could have the analysis that stating, okay, something like this. Mm. So as theta varies from 0 to pi over 4, r decreases from 2 to 0. So if this is 2, it will decrease to 0. And then take note something like this one. So parang ganito siyang mangyayari siya niya. Ganyan. Okay. Now, okay, as uh as theta varies from um you have pi over 4 to 2 pi, not 2 pi, pi over 2 rather, no points are generated on the polar graph. So since this is symmetric, then something like if we are going to flip it over in the y-axis, parang ganun yung, mayroon siyang ganitong mangyayari. And then if we are going to flip it over in the x-axis, so ganito mangyayari. Okay, assuming that they are really symmetric with each other. So this produces a portion of the graph, okay, that we had just do it uh, while ago. We can complete the graph by the reflection, which is what we did. Okay, so this is the propeller shaped graph, which is called limescate, from the Greek word. Uh, by the way, the spelling of limescate is this one, limescate, from the Greek word uh, limiskos, okay, which means loop ribbon, okay, resembling the number 8. So this is now the equation of the graph of the uh, r squared is equal to 4 cosine 2 theta. Because uh, if we are going to do the r equals negative 2 squared of cosine 2 theta, these two equations actually the same. The orientation only the matters because we start here, the other one will start at the lower portion. Okay, so the two equations are identical, superimposed limit state because they are just the same. Okay, let's have the family. Okay, um, let's the equation r equals a represents a circle of the radius a centered at the pole. So as a varies, this equation produces a family of circles centered at the pole. For families of you have um, the second and third. Recall from the plane geometry that a triangle that is inscribed in the circle with a diameter of the circle for the side must be a right triangle. Thus, it indicates that uh, you have the second one. Okay, this one, and of course the third one. The equation r equals 2a cosine theta represents a circle of the radius a centered on the x-axis and tangent to the y-axis at the origin. Similarly, the equation r equals 2a sine theta represents a circle with the radius a centered on the y-axis and tangent to the x-axis at the origin. Thus, as a varies, okay, so it produces a families uh, which are illustrated with this one. So in other words, if this is the if this is the equation, then it is a circle centered at the origin. If this is the equation, okay, so it is a circle the tangent to this line. Okay. And then of course half of it would be uh, in this portion. Okay. And if you have uh, another, okay, uh, if this is of course if this is negative then this would be here. Now if you have r equals 2a sine theta, then it would be tangent to this line but the circle lies above of this line. So you have r equals 2a cosine theta, so of course it will increase. Okay, so let's have family of Rose curves. So in the polar coordinates equations in the form of r equals a sine n theta and you have r equals a cosine n theta, in which a is greater than 0 and n is the positive integer, represents the families of flower-shaped curves called roses. The rose consists of n equally spaced petal of the radius a if n is odd and 2n equally represents the petals of the radius a if n is even. So take note that if it is odd, okay, the radius a, if n is odd and you have 2n, okay, equally spaced petals of the radius A if n is given, even rather. It can be shown that a rose with an even number of petals is traced out exactly once at theta varies over the interval theta greater than or equal to 0 but less than 2 pi. And the rose with an odd number of petals will trace or is traced exactly once at theta varies over the interval theta greater than or equal to 0 but less than pi. A four petal rose of the radius 1 was actually already given as an example. So the this would be the form if your n is equal to 2, so you have four petals. Okay, if it is uh, n is equal to 3, because this is odd, then you have three petals. Then if 4, then you have 8 petals. If 5, you have 5 petals. If 6, that you have 12 petals. And this would be the form of the roses or rose curve if you have a cosine and theta. Okay, let's have families of cardioids and limacones. Okay, so the equations with any of the four forms, you have r equals a plus minus b sine n theta, and r equals a plus b uh, a my a plus minus b cosine n theta. Okay, in which a is greater than 0 and b is greater than 0. So we have to take note that a and b should be greater than 0. Represent polar curves called limacones, from the Latin word limax, as a snail-like creature that is commonly called slug. Okay, so there are four possible shapes of limacones. They are determined by the ratio of a over b. Okay, so if a over b is less than 1, then you have a loop. You have the loop. Now, if a over b is equal to 1, okay, if we are going to divide that one, and it is exactly to 1, and it's a cardioid, cardioid rather. Not cardioid, cardioid. If the ratio between A and B is greater than 1 but less than 2, then you have the diplead limacone. Okay, limacone. So that one. And of course, if A over B is greater than or equal to 2, it's not a circle, but it's a convex limacone. So you have different types, okay, of graph. So you have, if A is 0.25, you have a very big loop here. If it is zero point 0.5, so you have here. If it is 0.75, then something like this. Up to A equals 2.5. Okay. So let's have families of spirals. A spiral is a curve that coils around the central point. So spirals generally have left hand rather, and right hand versions that coils in opposite directions depending on the restrictions on the polar angle and the sign of the constant that appears in their equation. Some of the more common types of spirals, okay, are actually shown in these figures, okay, for non-negative values of theta, A, and B. So you have the Archimedean spiral if you have r is equal to a theta, and then you have the parabolic spiral if r is equal to a squared of theta, and you have the logarithmic spiral if you have r is equal to a e raised to b theta. Then you have the Lipschitz spiral if r is equal to a over square root of theta. And you have the hyperbolic spiral if a is equal to, not a, r rather, r is equal to a over uh, theta. Okay, so let's have these examples. Okay, how we are going to graph the polar equation given that r is equal to 4 cosine theta. Okay. Now, to graph this equation, we have um, the first thing that we are going to do is we are going to construct a table of values using the special angles and their multiples. It is useful, okay? It is useful to first find the values that makes the uh, the r maximum, minimum, or equal to 0. So r is maximum and equal to 4 for the theta is equal to 0. R is minimum and equal to negative 4 for t, not for the theta is equal to pi. And r is equal to 0 for theta is equal to pi over 2. So in this case, okay, so in this case, if our theta is equal to 0, then our r is equal to 4. Okay. If our theta is equal to pi over 6, our r is equal to 3.5. If it is pi over 4, our r would be 2.8. You can use your calculators. If pi, if theta is equal to pi over 3, and then we are going to substitute this one here, your r, the r, it must be small letter r. Okay, small letter r. If we are going to substitute the theta by pi over 3, the answer is 2. If it is pi over 2, the answer is 0. If it is 2 pi over 3, the answer is negative 2. If you have 3 pi over 4, the answer is negative 2.8. You can use your calculator. 5 pi over 4, 5 pi over 6 rather, not 4. 5 pi over 6, that's equal to negative 3.5. If it is pi, is equal to negative 4. Okay. So, if we are going, take note that if we can stop at pi, because if we're going to continue, you will have the same values. So, the values will repeat. So, we can now plot the given points on the system of polar coordinates. So, we need to understand the plotting of points in the polar coordinates before we go to any further. So the system of polar coordinates with r equals the constant, and of course, our theta is constant. Okay, we need to pay special attentions to the points with the negative values of r. Okay, so if you have theta is equal to 0, then r is equal to 4, so you have 4, 0. So where is that? So here, 1, 2, 3, 4. So here. Okay. Next, if it is uh, pi over 6, so you have 3.5. Pi over 6, so you have here, somewhere here. Okay. And then if it is pi over 4, you have 2.8. Okay. 2 point, this is 2, so somewhere here. And then if it is pi over 3, that's equal to 2. Mm. And then if it is pi uh, pi over 2, it is equal to 0. So, andito siya. If it is 2 pi over 3, so where is that 2 pi over 3? So here. That's equal to uh, negative 2. Mm. So since r is equal to negative 2, so you have here uh, 5 pi over 3. So mm, here. Then you have negative 2.8, 3 pi over 4. So that would be on the 7 pi over 4. And of course, that is almost 3. Okay. And then you have negative 3 over 3.5, 5 pi over 6. That is equivalent to you have negative, uh, you have somewhere here 3.5, 3.5. So here. So that's 11 pi over 6, 3.5. And of course, you have uh, negative 4 pi. So trace, okay. So actually, if we go back to what we have discussed, the 4 cosine pi is actually the you have it is in the families of circle. So in other words, you have r equals 4 cosine pi. So this is a circle with a radius 4 at tangent to this line. Mm. That is what is being discussed in the previous slide. Okay, so let's have another example. So let's have this one. Graph the polar equation given by r equals 2 plus 2 cosine theta. Now take note that you have 2 plus 2 sine theta. That is actually, um, if you can still remember, that this is an example of uh, cardioids and lemmacones. Because r equals, take note from the previous slide, we have a plus minus b sine theta. Okay, so this is our a, this is our b. So if we are going to get the ratio between a and b, we could have a uh, over b, 2 over 2 is equal to 1. Take note from the previous slides, if a over b is equal to 1, then that's a cardioid. Okay. So in this case, this is a cardioid. Okay, we can now have the we can have uh we already have the what you call the overview of the graph. Okay. So if we are going to construct the table of values using the special angles and their multiples. Okay. So the R is maximum and equal to 4. Okay. For uh, pi over 2. Okay. If the theta is equal to pi over 2. And then R is minimum and equal to 0 if t or the theta is equal to 3 pi over 2. Okay. So let's make a table of values. If t is equal to 0, our R is equal to 2. If it is pi over 6, that's equal to 3. If it is pi over 4, it is 3.4. If it is pi over 3, it is 3.7. If it is pi over 2, that's equal to 4. If it is 2 pi over 3, that's equal to 3.7. If it is 3 pi over 4, you have 3.4. If you have 5 pi over 6, that is equal to 3. And then if it is pi, it's equal to 2. Take note that we are just not t, that is theta. Why I am using t here? It must be theta. Okay, take note that we are just going to substitute this theta to our equation. Okay, now let's try to continue because the values are not still, it is not repeating. So here, if it is 7 pi over 6, this is equal to 1. If it is 5 pi over 4, that's equal to 0.6. If it is 4 pi over 3, that's equal to 0.3. If it is 3 pi over 2, that's equal to 0. If it is 5 pi over 3, that's equal to 0.3. And then if it is 7 pi over 4, that's equal to 0.6. And then if it is 11 pi over 6, that's equal to 1. So we plot the points. We can now plot the points and join them with a smooth curve. So, of course, let's try to plot that one. Okay. So you start with 2. Angle 2, 0. Okay. Then next is you have 3.4. You have pi over 6. So this is the pi over 6. And that is 3, exactly 3. Okay. And then you have pi over 4. Pi over 4 and that is 3.4. So somewhere here. Then pi over 3, that is 3.7. So somewhere 1, 2, 1, 2, 3, 3.7. So here. Then you have pi over 2. That is exactly to 4. So 1, 2, 3, 4. Then actually uh, we, we can actually okay, by reflection para mas madali. So here because they are reflected somewhere here, there, and of course here. Ayan. Now you have 1, 7 pi over 6. So dito. 7 pi over 6 ito. And then 5 pi over 5. Tama ba ako? Okay, 5 pi over 4. So dito. And then 0 siya for 3 pi over 2. Okay, dito. 0. By reflection, we could have that one here. You have 7 pi over 4. Uh, dito. And you have 11 pi over 6, nasa 1. Mm. Then trace. Paano ba tayo? Trace, start with 0. Parang ganun siyang mangyayari. Okay. Okay. Ayan. So you have now the cardioid. Okay. Next. So graph the polar equation given that r is equal to 4 cosine to theta. Now, take note that that is 4 cosine to theta. So if that is the case, then that is family of rose curve. So you have the A is even, then the number of petals would be times 2. So in other words, you have 8 petals. Okay, you have 8 petals here, and then it is cosine. Therefore, the petals there would be 4 petals that is uh, intersecting uh, intersecting the uh, axis, okay, the quadrantal angles, okay, that is basically dividing the each there are four petals that is symmetric with each other. Okay. So to solve that one, we have first we are going to construct a table of values with special angles, of course, and their multiples. So r is maximum and equal to 4 for theta is equal to 0. R is equal to 0 and theta is equal to pi. R is minimum and equal to negative 4 for theta is equal to pi over 2 and 3 pi over 2. So if we have our theta is equal to 0, our r is equal to 4. If it is pi over 6, you could have 2. And if it is pi over 4, you could have 0. If it is pi over 3, you could have negative 2. And then if it is pi over 2, you could have negative 2. Not negative 2, but negative 4 rather. That's negative 4. If it is 2 pi over 3, you could have negative 2. If it is 3 pi over 4, that's equal to 0. If it is 5 pi over 6, you could have 2. Now, let's try to continue. If it is pi, that is equal to 4. If it is 7 pi over 6, that's equal to 2. If it is 5 pi over 4, that's equal to 0. If it is 4 pi over 3, that's equal to negative 2. And if it is 3 pi over 2, that's equal to negative 4. If it is 5 pi over 3, that's equal to negative 2. 7 pi over 4 is equal to 0. And the last one, 11 pi over 6, that's equal to 2. What we are just going to do is we are going to substitute this one to our equation. And you have now the values of your r. Okay, so what will happen? If it is 0, okay, r is 4. 1, 1, 2, 3, 4 here. If it is for pi over 4, it's equal to 2. So this is 4. So 1, 2. If it is uh, pi over... No, 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 no. I am wrong. Mm. If it is pi over 6 rather, it's equal to 2. Mm. If it is pi over 4, pi over 4, it's equal to 0. If it is uh, 3 pi, that's equal to negative 2. Take note, it's negative numbers. Actually, we can actually have a reflection actually in this case. Hmm. So here the reflection of this one. Okay, so let's get the reflection. So somewhere here. And then here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, here. And then here. Hmm. Then here. Then 1, 2, 3, 4. 1, 2, 3, 4. Then you have this one. Mhm. Then 0. Then you have this one. Then you have this. 1, 2, 3, 4. 1, 2, 3, 4. Okay, here. And then you have this one. Then back to 0. Okay. So this would be the K. Mm-hmm. Parang may kulang ata dito. Ay, parang may kulang ata dito. Kasi dapat, kulang nga dito. Dapat may dito pa. Hmm, para ganon. Tapos, ganon. Hmm. 1, 2, 3. Ah, it was before. Let me erase first. Ito ay dapat 1, 2, 3, 4. Ayan, nandito siya dapat. So, ganon ang mangyayari. Okay. So, that's the